I want to talk about functions and how we can reflect them. Now, what I have up here right now in Desmos is the graph of the square root of x. So let me just maybe start by pointing out the features of this function. Here it is. We've got like square root of 4 is 2. Square root of 9 is 3. So you can kind of see it's always increasing, but it's kind of like bent down. I guess I should have started with the square root of 1 is 1. So this is the square root. Now, the reason it doesn't appear anywhere else is because, of course, I can't take the square root of a negative number and get a real solution. I would get what's called an imaginary solution. So that's why there's nothing over here, because you can't take the square root of negative 4 and get a number. But also, the square root of x doesn't have any negative outputs either. Every square root I take gives a positive answer. So that's why there are no values down here. I'll never get a negative y value. So let's talk about reflecting this and moving this around. I'm going to start by putting a negative in front of my function and take a look at what happens. Flipped it down. It reflected it. Now, the reason it reflected it is because, as I said earlier, the square root function only returns positive answers. But then I put a negative on the front and I said, well, make every one of those positive answers the opposite. So now where it used to say, well, the square root of 4 is 2, now it says, yeah, square root of 4, but flip it to be negative 2. So we essentially find our answer and then just change the sign. Square root of 9 is 3, we made it negative 3. So adding a negative in front of our function flips the function over the x-axis. Now, I always think people memorize that. They say, well, you just reflected it over this axis. Reflection meaning like a mirror image. You took a function that was up here and flipped it to be down here. I would rather think about it like you changed your y values. You took the old answers and you made them the opposite. And yes, of course, that just flips us down over the x-axis. So that is one way to do a reflection. Now, another way to think about reflections is changing where that negative sign goes. So let me take this back. Let's put us back to the original. I'm going to put a negative on the x. Now let me explain what happened here. We said before that you can't take the square root of negative numbers. So this looks really strange. Well, how could I add the negative? Well, it's because if I put in, let's say, a negative 4 right here, put in a negative 4 for x, well, then I change the sign with that negative. So I have negative 4. Well, a double negative makes positive 4. Square root of 4 is 2. If I plugged in a negative 9, I'd have negative 9 as my x, minus negative 9 is 9. So square root of 9 is 3. So this made all of the opposite x values now able to be put into the function, where before I couldn't put in any negative numbers. Now I can. Of course, now the change of that is I can't put in any positive numbers, because if I put in positive 4, it would have a negative positive 4. It'd be negative 4. It doesn't work. That's why it no longer appears over here. So adding a negative to the x, like directly changing the x, changes what x values I can put in. So what that does is it spins us over the y-axis. So changing the sign on x reflects us over the y-axis. Like that. Putting a negative in front of the whole function changes our outputs and therefore reflects us over the x-axis. Now, in some cases, let's say you had a function like this, x squared. And you said, okay, if I put a negative in front, I'm going to add some parentheses like that. If I put a negative in front of the function, there it is, flipped it. Put a negative in front of the function, reflects all of my outputs, reflects me over the x-axis. But if instead I did this, I put a negative on the x, and then I did a squared like this, notice how it looks exactly the same. And the reason it looks exactly the same is, of course, this is symmetric about this axis, meaning you can kind of cut it in half and it's a mirror image. So it did get reflected, but it just got reflected onto itself. So essentially all of the values over here got put over there, and all of the values over here got put over there. So it just ended up being reflected on itself. And that just has to do with symmetry. So what we should get out of this is this. If I have a function and I put a negative in front of it, I take that function and reflect it over the x-axis. Basically, I flip all of the y values to be their opposites. If I add the negative directly onto the x and I change the sign of x, that changes the x values that I can use, and that flips us over the y-axis. If this video helped you, please like and subscribe for more math help.